introduce something that we haven't had before, and that is the word capacitance. I will define the capacitance of an object to be the charge of that object divided by the potential of that object. And so the unit is coulombs per volt. This V is volt now, it's potential. But we never say that it is coulomb per volt in physics. We write for that a capital F, which is farad. We call that 1 farad is the unit of capacitance, undoubtedly called after the great maestro Faraday. We will learn more about Faraday later in this course. So let us go to a sphere which has a radius r, and let us calculate what the capacitance is of this sphere. Think of it as being a conductor, and we bring a certain charge Q on this conductor. It will then get a potential V, which we know is Q divided by 4 pi epsilon 0 r. We've seen it many times. And so, by definition, the capacitance now is Q divided by the potential, and therefore this becomes 4 pi epsilon 0 r. So that is the capacitance of a single sphere. And so we can now look at the values as a function of r. I have here some numbers. I calculated it for the Van de Graaff, and I calculated it for the Earth. If you want 1 farad capacitance, that's a real biggie. You need a radius of 9 times 10 to the 9 meters. That's the 4 pi epsilon 0 that comes in there. That's huge. That's 25 times the distance from the Earth to the Moon. That's a big sphere. We have a capacitance of 1 farad. The Earth itself, with a radius of 6,400 kilometers, would have 700 microfarad. The Van de Graaff 30 centimeters radius would be 30 picofarad. The pico is 10 to the minus 12. And if you take a sphere with a radius of 1 centimeter, then you have roughly 1 picofarad, 10 to the minus 12 farad. So this gives you a rough idea about the size of objects and how they connect to their capacitance. So if I bring all these spheres at the same potential, so I charge them all up to the same potential, then the one with the largest capacitance will have the most charge. And that, of course, is where the word capacitance comes from. It is the capability of holding charge for a given electric potential. Don't confuse that with electric fields, because if you bring all these spheres at the same potential, then the one with the strongest electric field, that's the one which has the smallest radius. We discussed that last time.